Your Active Directory is already a target. Right now, attackers have a checklist and most Windows networks hand them the keys before IT even gets there. Morning coffee. Active Directory, AD for short, is the system that controls who logs in, what they can access, and who's an admin on your network. It's the crown jewel, and there are specific attacks designed to steal it in minutes. Let's talk about how it happens, and how you stop it. Think of Active Directory like a master keychain. Every user, every computer, every permission on your company network. It's all stored there. On a domain controller. One server to rule them all. That's exactly why attackers go for it first if they compromise AD. They don't just own one machine. They own every machine, every share, every email, every password hash in the building. And here's the scary part. Most of the attacks I'm about to show you don't use exotic malware. They use tools that are free, open source, and downloadable in 30 seconds. The first attack is called Pass the Hash. When you log into Windows, your password gets converted into a hash. Think of it like a scrambled fingerprint. Windows stores that fingerprint in memory. It uses it to authenticate you without asking for your password again. The problem: attackers can steal that fingerprint and use it directly. They never need your actual password. A tool called Mimikatz, one of the most famous hacking tools ever written, can dump those hashes from memory in seconds. Then the attacker replays that hash to log in as you. As an admin. As anyone. The second attack is called Kerberoasting. Stay with me. The name sounds weird, but the concept is simple. Kerberos is the authentication system AD uses when a service runs on your network. A database, a backup agent, a web app. It runs under a service account. That account has a password, and that password is baked into a ticket that any authenticated user on your network can request. Kerberoasting is when an attacker requests those tickets for every service account, then takes them offline and cracks the passwords with a GPU. No noise, no alerts, just silent brute force on their own machine. If those service account passwords are weak, and they usually are, it's game over. This one is the endgame move. It's called DCSYNC. Domain controllers. The servers that run AD need to sync with each other, replicate their data. That's normal. But DCSYNC is when an attacker mimics that replication process and tricks the domain controller into sending them every single password hash in the organization. Every user, every admin, the full database, delivered straight to the attacker. To run DCSYNC, you need one specific privilege: replicating directory changes. If an attacker has that through a compromised admin account, they can run this from any machine on the network. And with those hashes, they forge a golden ticket. A Kerberos authentication pass that never expires. Literally permanent access to your network. Here's where it gets really interesting. Before attackers even run these tools, they map your AD like a blueprint. Bloodhound is a free tool that visualizes your Active Directory relationships as a graph. Who has admin rights where? Which service accounts are overprivileged? What's the shortest path from a standard user account to full domain admin? It's like Google Maps for hackers. Enter here. Turn left at the misconfigured GPO. Arrive at domain admin in 4 steps. The terrifying part: Bloodhound runs as any authenticated user. No admin rights needed to start the recon. Okay, now you know how they attack. Here's how you fight back. First, implement the Microsoft Local Administrator Password Solution, called ITLabZA. It gives every machine a unique local admin password. Pass the hash attacks break immediately because stolen credentials from one machine don't work on another. Second, use long, complex service account passwords. 30 characters minimum. Kerberoasting only works if the crack succeeds. A 30-character random password? That GPU can run until load shedding ends and it still won't crack it. Third, audit who has the replicating directory changes permission. That list should be tiny. If a regular user account has it, someone messed up. Or worse, an attacker already did. Fourth, run Bloodhound against your own network. Seriously. Find your attack paths before they do. It's free. It's legal on your own domain. And it will show you things that shock you. And fifth, enable advanced audit policies in Windows. You want to log Kerberos ticket requests, LDAP queries, and replication events. If you can't see the attack, you can't stop it. Now if you're building a home lab here in South Africa, tight budget, maybe running Proxmox on an old Ryzen machine, you can practice all of this legally and safely. Spin up a Windows Server 2022 VM as your domain controller. Add a Windows 10 client. Join it to the domain. Then spin up a Kali Linux VM. That's your attacker machine. Everything I showed you today, Mimikatz, Impacket, Bloodhound, they all run in that lab environment. No real network. No legal risk. Pure learning. If your machine can't handle 3 VMs at once, I've got a resource guide on Gumroad. Link in the description. That covers lightweight lab setups that survive load shedding with a UPS under 1,000 Rand. Active Directory attacks are not theoretical. They are happening right now. On networks just like the ones you manage or will manage. The difference between a junior sysadmin and someone who actually protects their organization. Knowing this stuff before the attacker does. If this gave you something real to work with, subscribing helps me make more of it. Hit the bell. I drop new content every week. Drop a comment below. Have you ever run Bloodhound on your own ID? What did you find?